In this video, I'm going to show you 6 common mistakes that Java developers often make. One of those common mistakes is not using optional. In this case, I have this method called getVirdDate. This method receives a username and it returns null if the optioner is not shown, otherwise it returns an offset date time. So the issue with this method is that I'm doing operation over the result that may be null. And the only way for me to know that this method return null is by taking a look at the code. And what optional solve is that it let callers know that this method may not return the information you are looking for. In this case, let's fix this. Let's use optional over here, and then optional over here, here optional empty, and let's save this on a variable. Perfect. And this optional off. Nice. So over here, now it's return an optional, and let's use this cool method called if present, then execute this. Let's see what happens. It doesn't print anything because it returns an empty optional, but if I change this for John and I print this, in return is sort of older than 10 years old, true. Using equals incorrectly is a very common mistake. In this case, I have this variable called brand that's called the getBrand method. And the issue over here is that the brand variable can be null. And over here, I'm comparing the brand against a constant. And if I execute this, I'll get a null point exception because this is null. An easy fix for this is basically have on the left side the variable of the value that I know will always has a value. For example, in this case, let's use BMW, and here let's use brand. So in this case, it should work, and it's because in case of brand is null, this will return false, and if it has value, it basically will compare against that value. A common bad practice is to create a method to mutate a list. In this case, I have this method called addStudent that receives a list of a student and a course ID. If the course ID is greater than 0, then it adds to a student. The issue is that it's not very good practice to have a method that mutate the list, because maybe in the future someone will take this list and will modify it beyond adding the student. Let's say that someone incorrectly tried to remove some of the students, and if this method is being used across many other classes, it could get very bad. So the fix for this is, instead of mutate the list, let's return a list. So let's say this string, instead of having this string students, return list students. Over here, list of. Looks great. Now let's remove this. Let's save this. Students to add, and students add all. Students to add. And let's print this out. Students. awesome. So anyone can call this, and basically it won't ever mutate a list. It just return a new list, and the caller that need the list, they can do whatever they want to. Using too many conditions unnecessarily is a very common bad practice. In this case, I have this method called getID. It receives a person, and if the person name is Luffy and his age is 17, then it returns an ID. And this method is very simple. However, it looks so complex because of the many conditions. A very good way to refactor this method is to fail fast first. It means basically take all the conditions that make the method to fail, put that in the beginning, and after that you can put the logic assuming that everything after that should work. So let's refactor this a little bit. If person name equals Luffy, let's return an optional empty. If person age is in 17, then let's return an optional empty. And otherwise, let's return this. Looks better. Nice, and we can even improve this by doing the following. So it looks like much more simple now. All the conditions that should fail fast are in the beginning, and after that I can put the logic that should work, and it looks much better for the reader. Java has introduced new ways to cast objects. Usually we see this. In this case, I assign a variable called name with the value 0. Then over here, I do an instance of to make sure that the object is a string. Then I cast the object to a string. Java introduced this new way where I can put over here, let's say name a string, and if the name is a string, then a new variable will be created called name string, and I can use that variable which will be a string variable. Let's see. And nice, it works, and the code looks much more readable. Not knowing the data structures that Java provides is a very common mistake. In this case, most developers know about array list, hash set, and hash map, and the reason is they want a list of something, but they don't want to specify the size, so they just use array list. And then they found a case where they need to have a list of something, but they want it to be unique. Then they discover hash set. And with hash map is because they need a key value structure. However, even though they know these three data structure, they don't understand them. They don't know the space complexity. They don't know the time complexity, and this is very important. So they don't know why hash set provide unique elements and why hash map the key of the hash map should be unique. And I believe this is very important, and even more important to senior developers that sometimes have to coach other developers or at least review PRs. And most of them also don't know about the rest of the data structure. And I think this is very important because you may have to face a ticket where you have to handle a lot of data and you want to speed up that process and knowing and understanding the data structures that Java provide. It is very important and good. If you really like this video, please subscribe.